All right, so we're going to start off with definitions because anytime you start a new topic, especially something brand new, there's lots of definitions. I mean, you guys in geometry, you know that there were lots of definitions. All right, so let's start off with angles. Okay, so let me draw in an angle. Okay, in trig, first of all, this is called standard position. This is called standard position because my angle is drawn on the x-axis. Standard position is any time that your initial side, which this here is called the initial side, is on the positive x-axis. That's just called standard position. You could put the angle wherever you want to, but it makes it a lot harder to do anything. So normally, anytime we're dealing with an angle, we put it in standard position. It doesn't change the size of the angle at all. It doesn't change what you're doing with the angle. So it's just a lot easier if you put it in standard position. This side here is called the terminal side. And then, of course, we have the actual angle. The angle is the distance between the two sides. It's the measurement between them. So again, that's just some basic geometry. Only other thing that we might put in here is, this doesn't matter to us a whole lot, but this is the vertex. Okay, let me put in a couple angles here. Yep.
Can you measure angles on circles?
Yeah. Yep. Okay. First of all, here, let me put in all these little symbols. Okay. Can't think of any more off the top of my head that we're going to use. Those are Greek letters that they use to represent angles quite a bit. Alpha looks like a fish. Beta looks like a bee with a tail. Alpha is a lowercase alpha. Beta is an uppercase beta. Omega is a lowercase omega. Theta is an uppercase theta. Why we switch back and forth between uppercase and lowercase, I don't know. But I'm going to use some of those, so figured I would give them to you, and it's easier if I just give them to you like that. Instead, explain each one as I use them. Okay. In this case here, okay. Anytime you go counterclockwise, those are positive angles. If you go clockwise, those are negative angles. And we'll talk about how to measure angles here in just a little bit. But anytime we go around in this direction, that's positive. Anytime you go around in this direction, that's negative. So we get another thing happening here. Is that we can have angles end at the same spot. If we have angles end at the same spot, those are called coterminal angles because they have the same terminal side. Now, an angle, any angle actually has infinitely many coterminals because I can actually take this and I could go like this. See if I can do this without messing up my picture too much.
What does the term coterminal mean?
It means they end at the same terminal side. So alpha is actually a coterminal also. I can go around as many times as I want to. So there's infinitely many, and I can go around in either direction. So that's why there's infinitely many coterminals.
Like you're meaning like 360 degrees is coterminal to 0 degrees?
360 is coterminal to 0, which is also coterminal to 720, which is also coterminal to negative 360. I'll make sure I don't miss any definitions, but I think the only other thing I wanted to define on this page was quadrants. Okay, quadrants, hopefully this is a review. Your quadrants, this is your, why they use Roman numerals, I don't know, but this is first quadrant, second quadrant, third quadrant, and fourth quadrant. That's just the definition of your quadrants. So first quadrant is positive, positive. Second So I'm going back over that because I know in algebra and stuff we define quadrants, but we don't usually stress them too much because we don't use them for anything. We're going to do the same thing here. I'm redefining them. We're going to use them a little bit, and then we're going to move on from them. We're not going to use them a whole lot. All right. Am I okay to move on? Okay, we have two ways of measuring angles, degrees and radians. Degrees is used the most, but it's kind of arbitrary.
What's arbitrary?
Arbitrary means it was kind of randomly made up. Radians actually has meaning behind it, but it's not used very much. It is used a lot in mathematics, but outside of mathematics, it's not used. If you take a science class or an engineering class, you're going to use degrees. If you're in mathematics doing actual just straight math, you're going to use radians because radians works really well mathematically because it actually has meaning behind it. Degrees, the definition of degrees is 1/360th of a circle. Yeah. Yes. Yep. And you're going to learn how to switch back and forth. Not today. We'll learn that later. So, kind of arbitrary. I don't know who decided to split the circle up into 360. But if someone had decided to split it up into 400, then it'd be 1/400th of a circle. Someone decided on 360. You know, like someone decided 12 inches in a foot. But that's degrees. Everything has a story behind it. I don't know the story behind this. Yep, shame on me. So, important parts of a circle. So, there's 360 degrees in a circle because, 360th of a circle is 1 degree. 90 degrees makes a right angle. 180 degrees makes a straight line or a semicircle. So just to finish it off, 270 is down here. And again, you guys are used to working with degrees. Important degree measurements that we're going to be working with are 30 degrees, 45 degrees, 60 degrees. We're going to be doing geometry with, your 30, 60, 90 triangles, 45, 45, 90 triangles, that kind of stuff. Okay, radians. Radians actually has meaning behind it. The definition of a radian That shouldn't be 1 radian. There, now it's equal to 1 radian. So what this is saying is if I take a piece of a circle and I want to know the measurement of the angle in radians, I take the length of the arc, which let me say that's S. So we're talking about the length of it, actual measurement of it, divided by the radius. Now, what happens though is think of the circumference of a circle. It involves pi. So, 1 time around the circle is equal to, actually, what we do is we use a unit circle. So we make the radius equal to 1. Because what you find out is it doesn't matter how much the radius is. Because remember, let's do this. I'm going to do a full circle, okay? 2 pi r divided by the radius. So I'm doing a full circle, okay? What happens to the r's? They're removed. So it really doesn't matter what the radius is. So to make calculations easier, what we do is we talk about a unit circle. So we just make the radius equal to 1. Then it really doesn't matter. So 1 time around the circle is equal to 2 pi. So what's halfway around the circle? Pi. So 90 degrees corresponds to pi over 2, or 1/2 pi. So down here we have 3 pi over 2. We don't use the whole numbers because the whole numbers correspond to these points. Random points out in the middle. They don't do us any good. Some other important ones. 45 degrees corresponds to pi over 4. Pi over 6 corresponds to 30 degrees. Pi over 3 corresponds to 60 degrees. What's 120 degrees going to be? Two pi over 3. 120 degrees is 2 times 60, right? So it'd be 2 times pi over 3, which would be 2 pi over 3. So one thing you have to get used to doing this semester is dealing with fractions. Now, this whole definition of radians is great. I'm not going to ask you where radians comes from. It's great to know, to see. I'm more wanting you to be able to use radians than I'm not going to ask you on a test, okay, state the equation where radians come from. I'm not going to ask that. I'm going to ask you to be able to use them. Okay, so speaking of using them, we need to actually do something. Everything we've done so far is definitions. We haven't done any work. So we actually need to do some work. So let's start with being able to move back and forth between degrees and radians. Now, this is as simple as setting up a proportion. You pick a place on a circle that's easy to use and just use a proportion to convert it. Easiest place to use that is equal is right there, because it doesn't require any reducing. Now, there's two ways of doing this. One way is you can take and you can multiply by the fraction, like doing unit converting. The other way you can do it is you can set up a proportion and you can use cross multiplying. I don't care which way you do it. I can show you both ways. It honestly doesn't matter. Either way will get you the correct answer. Now, notice radians. Radians doesn't have a symbol or a units that goes with it. Degrees does, radians doesn't. Okay, so let's try a couple. But that's all that there is involved with it. It's just like converting from feet to inches. All right, so if I take 120 degrees, let me start off by just doing a strict conversion. Okay. Here's my converting factors. If I want to get rid of degrees, does degrees go on the top of the fraction or bottom of the fraction? Bottom. So I put pi on top. So my degrees cancel out. And then all I need to do is reduce my fraction. So 12 over 18 is 2/3. There I go. I converted 120 into radians. Okay, the other way to do it is you can set up a proportion. Degrees are on top, radians are on the bottom. So this actually needs to be an X, sorry, because I'm looking for that. So on this fraction, I need degrees on top, radians on the bottom. And then I simply cross multiply. Yep. 180 is equal to pi on our circle. They're in the same spot. You could use anything. I could use pi over 2 and 90. It's just the calculations are the work. This is the place where the calculations are easiest. Okay, reduce that. I think 180 is actually divisible by 15, but just a second. There you go. So, those are your two ways of doing it. I do not care which way you do it. Pick one. Don't try doing it back and forth both ways. You just need to choose which way you prefer. Okay, since this is radians, I need radians to go on the bottom. This one I'm lucky enough that the pi's cancel out. So I get 10 degrees. Okay, this one's in radians, so radians is on top. So I need to put radians on top over here. Cross multiply. Okay, this is in degrees. I don't have pi in degrees, so I need to divide that out. Okay, one more topic real quick. Good with that? Give me it. Good. Okay, complements and supplements. Okay, complements, wherever you add them together, what do they equal? 90 degrees, or what in radians? Pi over 2. Supplements, or pi. Okay, that's really all you need in order to do the problems. This is really just an exercise in doing fractions. Because doing it in degrees and stuff, most of you should be okay with. So if I want to do part A, if I want the complement of 15 degrees, how do I do that? Yep. 90 minus 15 is 75 degrees. Okay, so for part B, how do I find the complement of pi over 12?
Put back in degree.
Pi over 2 minus pi over 12. Okay, pi over 2 in 12ths would be 6 pi over 12. So it'd be 5 pi over 12. Changing it to radians does not change how you do the problem. If they give you a problem in radians, your answer needs to be in radians. You don't need to be changing back and forth between degrees and radians. Because the goal today is that you learn how to use radians. Because you don't want to be converting back and forth all semester long. Okay, supplement of 73 degrees. You do what? Which is going to be 107 degrees. Okay, supplement of 2. No. Oh, yeah, sorry. No, you're pi minus 2. Believe it or not, I actually split section 4.1 in half. We're not even done with it. That's how much information's in it.